So question number 9 is again another proof. So I'm just going to look at the bottom. First of all, they do tell me at the top that it's a parallelogram, and they tell me they want us to prove triangle ABC, which is this one, is congruent to ACDA, which is this one. So I'm going to see what they ask us to do at the bottom first. And at the bottom, if you notice, it says we need to label the diagram, and then we need to fill in the missing statements and reasons for the proof above. So I will do that. So the first thing we start with is what they give us. And they gave us that it was a parallelogram. And that's really important because then we know the sides are parallel, which is actually what they have in part 2. They say that BC is parallel to DA and that AB is parallel to CD. And you can't write given anymore because what they gave us was that it was a parallelogram. But these two properties are actually the definition of a parallelogram. So that's what we write there. I let my students write def. So definition of parallelogram. So now we have the next statement, which says angle BCA. So I'm just going to trace that. BCA, that's this angle, is equal to DAC. And hopefully you know that is because they are alternate interior angles and they are equal because the lines are parallel. So right now in our proof we have 1A. Hopefully, just a reminder, you know there are 5 ways to prove that triangles are congruent. Either 3 sides, side, angle, angle, side, angle, angle, side, and hypotenuse leg. And hypotenuse leg is only for right triangles. So this one is clearly out. So I'm just going to continue my proof and see which one of these I end up with. Now the next part is totally blank, but the one after that does say AC is equal to AC. So hopefully you know this, and that is the reflexive property. So I'm going to write that right here in number 5. That is the reflexive property. So now I'm missing something because the next line is the end. So I'm actually going to fill in the end real quickly for you. The end is to prove the triangles are equal. So we'll do that. So triangle ABC is congruent to CDA. So triangle ABC is congruent to triangle CDA, and I need a reason. And if we look back at our markings, all I have right now is one side here and one angle here in both. So I have one angle and one side, and that's definitely not enough. So I need something else, and hopefully you remember that not only is it parallel this way, but we have parallel going in the other direction. So we have these lines that are parallel. And what they create are 2 more angles. So this angle here would have to be equal to this angle here. And what that will give me in my triangle is another angle so that I could do ASA. One angle right here, one side here, and one angle here. So I just have to mark that angle BAC and DCA are equal in the proof. So angle BCA is congruent to angle DCA, and the reason again is that those are alternate interior angles and they are equal if the lines are parallel. So if you look at this one more time, first we began with it being a parallelogram, and then the next line they told us were that these opposite sides were parallel, and that's the definition of a parallelogram. they gave us our first angle right here, this one, and that's in line 3, and those are alternate interior angles. And since we had 2 sets of parallel, right, if you look here, we had 2 sets of parallel, then we have more alternate interior. So these angles are congruent to these angles because of like an N or a sideways Z. And those are also called alternate interior angles right here. The last part that they gave us before we could finish was the reflexive property, and that was side AC is equal to itself. And if you look at my picture now, I have ASA as the reason why they are congruent to each other. In question number 10, it says find the value of x that will make these parallel. Well, the only way that line S and line T are parallel is if these angles are actually equal to each other. And the names of those angles are alternate exterior angles. And then they want me to find the value of x. So I'm just going to solve 7x minus 9 equals 6x plus 16. So when I did that, I got that x was equal to 25. Sometimes they want us to find the actual value of that angle, so you would just have to substitute it in. In question number 11, they ask us to use AB and construct an equilateral triangle with a compass and a straight edge. This is going to be a little bit difficult for me to show you, but hopefully you'll get the idea. So first of all, if I had a compass, I would put the center right here, and then I would look for the dot or for the point that matches there. And what I would do on B is I would make a triangle, I would make a circle that looks like that. And then I would move the compass over to this side using the same part. So now I would put the center over here, and I would mark another arc with the same radius, so part of a circle. And then hopefully you notice that they meet at a point right here that is the same distance away. And if I connect this length and this length, you will get an equilateral triangle where all the sides were equal. Question number 12 says we're given angle 1, which is 3x plus 16, and we're given angle 2, which is 5x minus 12, and they want us to find the measure of angle 2. So hopefully you know that these are called vertical angles, and they're equal to each other. So I'm going to set an equation and solve 3x plus 16 equals 5x minus 12. So when I solved, I canceled these, and I got x is 14. And a lot of students stop there and give us that answer. Unfortunately, they don't want us to just solve for x, they want us to find the measure of angle 2. So I'm going to take 14 and substitute it in there and solve. When I substitute it in, my final answer is 58 degrees for angle 2. And believe it or not, if you would have done the same thing with angle 1, you should also get 58 because they're always equal. In question number 13, it says, Laura says all rhombi or rhombuses are parallelograms. So here's a picture of a rhombus, and it looks a little bit like a parallelogram. But then Marianne says all parallelograms are actually rhombuses. So they want to know who is incorrect. Well, parallelograms are very general. Believe it or not, a rectangle, where these sides are equal, these sides are equal, and we have right angles, is actually a parallelogram. But this is not a rhombus, because in a rectangle, not all 4 sides are equal. So that means that Marianne is wrong. And so I'm going to put that real quickly. Marianne is incorrect because a rectangle, and you could think of some other shapes too probably, but for sure a rectangle is a parallelogram, but not a rhombus. And that's because all 4 sides in a rectangle are not equal. In question number 14, they ask us to find the area of the shaded part. So I'm going to find the area of the triangle first, which you know is base times height divided by 2. And it looks like the height is 5 because they put that over there, and the base is 10. So 5 times 10 is 50, and divide by 2 and you get 25. So 25 is the area of this whole thing. But I don't want this part in the middle. I want to get rid of that. So I have to subtract the area of a rectangle, which is just base times height. And in my case, that's 1 times 6, which is just 6. So I'm going to subtract those two to find out just the shaded part. And that would be the total area is only 19. In question number 15, they say find the area of a trapezoid formed by the following points: 0, 0, 1, 3, 5, 3, and 6, 0. So they want us to find the area of this trapezoid. One way to do that is to know the formula for a trapezoid, and I think this is the easiest. So we need to do base 1 plus base 2 times height divided by 2. And in our case, one of the bases, if you count, is 6. This base over here is only 4 squares. And then the height is straight down the side here. So the height in our case would be 3 divided by 2. So 6 plus 4 is 10. 10 times 3 is 30. And 30 divided by 2 is 15. Now the other option you have is you could divide this up if you wanted to. And you could find the area of this piece, which is a rectangle. And that's 4 by 3, so this part is 12. You could find the area of that triangle, which is base times height divided by 2. In our case, that's 1 times 3 divided by 2 is only 1.5. And this triangle is the same. It's also 1.5. And if you add 1.5, 12, and 1.5, you will still get 15. I think it's easier to use the trapezoid formula.